Then I need to do a program. So this is training. And then I need to import my CAD model. So under this, import my CAD model. And my CAD model. Okay, so I will do my 3 main steps. First, to delete the PCS, which is the part coordinate system. And then second will be the palette coordinate system. So I will reset both of them. And then the third step will to set up my machine setting. So this general, I set my measuring distance, search distance, as well as the retraction distance, and positioning speeds, acceleration speed, and so on. So you can set up your stuff.
Yeah, 明天跟他讲10点。
Okay, then I will put a comment. Then I start to do the manual alignment. So I will do a plane, line, line. So plane, click on the CAD model, and then activate my joystick, and then take some points. So 1 point, 2 points, 3 points. You can see that I have already took 3 points by seeing at this small green dot. Yes. Then terminate. And then set up my primary directions in a positive Z direction for the primary directions and Z for the origin. Okay, so you can see the coordinate system is aligned in the primary directions. And then I measure a line. I need to check my reference. It can be the plane 1 and also can be a XY plane. It's the same. So for line, 1 click and second click and then right click. And then activate the joysticks. And then the second point. Okay, that's it. And then next steps is my secondary directions. So in the following the positive X directions and Y for the origin. And then the last one will be my point. My line. So reference, we need to check also. So I want to take a line here, so it will be XY plane. And then 1 point, 2 point. And then the next steps, activate my joysticks. 1 point and 2 point. Okay. And then one last step is to set the origin, X. And then after this, we need to save it. So save as a manual alignment. Okay. So this done my manual alignment. Then the next step is I need to done my do my auto alignment. So I put a command. So still for auto alignments. And then most important one, I need to open up the CNC on. So CNC on is at here. Sometimes you might unable to find the CNC on is because if you click on the workspace here, it will show you the graphic tools. So what you need to do is you need to click somewhere in this program area. So it will show you the program tools, and then you click this CNC on. So yeah, and then the next one, I just will repeat the manual alignment steps, but this times I will not using the joysticks. So first left click and right click, and then go to distributions, and then to check out the distributions method that I want, as well as all these parameter, and also this safety plane. Okay, if everything is fine, you think that no collisions, everything is good, then just next steps will be setting up the primary directions. So all these parameters will still be the same as in what we have in the. Then the next step is to set up the line, and then my reference still is a XY plane. So one line, 1 point, 2 point, and then right click, and then go to distributions to check out the points I need. Okay, and just press. Okay, the next one is set up the secondary directions, positive X and Y. Okay, and the next one, line. Then check my reference, 1 point, 2 point, right click. Okay, make sure that it is not going to the hole, and then go to distributions. Okay, everything is good, and then just. Okay, then the last one is set up the origin X, and then save it. This will be the line. Okay, after this, I can start my measurement already. So put the comment also. So this is my, starting from here is my measurements. So I can measure all the circles, slots, everything. So let's say I open up the head probing first. So this one. And then I can also set a range for it. So later I can take many points, many circles together. Okay. Then I want to measure all these circles as well as the circles beside. So I put. And then remember that you need to set your reference to nominal value. Okay, if not, the reference will be different for this circle and the top circle. And then it might cause some collisions. Okay. So first, now it's a hand tool. Remember that I need to click on the element. I need to make it to something like a cross cursor. So in order to activate it, you need to click this mouse tool. If this is deactivated, okay. So your cursor need to be like this. Then I also need to measure this one. Sorry. So the first step I miss out is because I need to measure many circles. So I need to open up these repeat functions. So as you can see, just now I didn't open, so it's only none. So it's now I need to choose, so it's manual. So 1, and then 2, 3, 4, 5, and 6. So after that, I need to check whether is everything correct. Okay, so we can see that this circle might not be correct. So we need to, so let me choose again. So 1, 2, 3. 4 and 5. Okay, and the next step is I need to go to check out the distributions. Like how many points I need, maybe 4 points is enough, and all the depth and so on. And it's a full circle, and I don't need a edge distance. And this is the safety point, all these red points. So what I can do now is just everything okay, then just so the collision has been calculated. Okay, let me start first. Okay, so I have measured all the 6 circles together. So I've measured from circle 1 to circle 6 in one go. And then now I can see that my probe is still inside the hole. I can move it outside by move in negative y-axis, and then put an intermediate point. This is one of the way. Okay, then I can measure this cone also. So measure the cone, and then I don't have a plane right now, so I can straight away use a nominal value because I have a cap model. So left click and then right click. And then the next steps is to adjust your distributions. All these and your depth. So I need to make it outer a bit and then maybe 3 circles. And all the safety points. Okay. That's it. Okay. So I have measured these also. Then I can what can I still measure? I can measure this plane. Okay. So I can measure this plane. And then I would like to turn off this head probing first, and then to take some points. And the same method is you need to adjust your distributions, parameters, all this. Okay. Okay, then the next steps is I want to move the props up. So I can use these functions as mentioned yesterday. So just one click on here. And then okay, I can move up first. So maybe 100. So it will move up. And then I can rotate the head to A0, B0. Okay. Then I can start to measure this slot. So to measure a slot, a bit different. So first I set up the reference first, XY plane, and then I need to select the slot is click on the plane near to the slot. So it will detect the slot automatically. And then the next step is adjust your distributions. Okay. Same for all these. If I want to measure this plane, this as a plane or as a line, so let me measure some of these so later we can have more elements for the constructions. So I can use this manual mode also. So I can set up the points myself. Then I can measure this as a line. Okay, then the next steps, I want to measure a curve. Measure a curve at here. So same as yesterday, I need to edit and then insert the curve first. First intersect with the plane. So I can simply choose this plane, the plane with the green surface, or I can select the ZX plane. It's the same. And then offset. So let's say today I need to offset 8 mm and then insert and then save the save my this curve which is in the SAS format. So you can rename it. And then I measure this curve. So click the measure curve and then left click and then right click this curve. And then I only need a part of it. So set up a boundary. So delete it and then set up 1, 2. So these are my points. Okay. So what I can do is just start. So this is how we measure a curve. And then one last one is I want to measure a surface. So you click it and then choose on this surface, left click, right click, that's it. Okay. Then we can change here also the distributions. If I think everything is okay, I don't want to change some things, I can proceed to start. Okay, so I got what I need to measure. So I think I'm okay. So I just move up the props. That means I done my measurement. Okay, so right now I think everything is clear. And then the next part we are going to I'm going to talk about is about the constructions here. So I will make use of what I have measured just now, and then try to construct what we can construct. Okay. So the next steps, I will also make the habit to put a comment, and then do the constructions. Okay. So starting from here, I can construct what I cannot measure, like intersections of two lines to make a point and so on. Okay. So first, so let's start with these intersections. So intersection means that we are we have two lines, and then two lines intersect with each other, they will form a point. Or maybe 2 points intersect with 2 planes intersect with each other, it will form a line and so on. So first, I will find an example. Like let's say I need to have this line 3. Am I right? Which is the line 3 and the line 4. Okay, we can have few methods to select the elements. You can either click first and then click on the intersections. So this source will automatically adapt from the element window. So left and right will be automatically adapt inside here. Or you can simply choose it from here by the drop down list, or maybe open up this folder, and then you can also see the nominal see the actual value, the XYZ, as well as the directions and then the range and when you mentions and so on. So here you will have more informations. Okay, so you want to choose from here is another method is also the same. Then you can swap here and there, because sometimes the order of the elements might have different results, and so this is the source. So source means that what you have measured before, means that what you need to use, and then I want to use 2 lines, so the 2 lines will be my source, and then the target is what I want to produce. So just now I mentioned that 2 lines will produce a point, so my target will be a point. So you can see that here I have only one solutions, which is the point, and then this point underscore 1 will be the name of my point, which is the point 1. You can adjust it like you want a point 2 is okay, but you don't choose from the drop down list here. So if you choose from the drop down list here, like circle once, then you press sharp. So this will override the data of the circle one, which means that you will don't have circle one anymore, but the circle one will be a point. Yeah. So what I need to do is this is a point once, and then here will be the nominal value, which means that this value is comes out from the intersections of these 2 lines, of the nominal value of these 2 lines. So it will form that 0, 0, 0 and 0, 0, 1 for the directions. Okay. Then after we construct, we can see the actual value on the element window. Okay. So let's see. So just now this is our point 1, and then just now we can see this nominal value is all 0, and then I said the k is the directions is 1, and then after we measured the part will have some deviations, so the actual values is 18 microns differ in x directions. So we can only see the actual value after we press the construct. Okay, so this is to intersect a point out of 2 lines. We can also have another solutions like we have this plane tree, which is the circle on the which is the plane on the green surface, and we also have this cone 1. So I want to intersect 2 of these. So basically, if I use a cone and a plane intersect with each other, first I will get a circle, and then the next one is I will get a point. So I will show you guys. So intersections of first is a cone and plane 1. So add that from the element window. So these 2 are my source, and then the next one is the target. So you can see just now I mentioned that for a cone and a plane we can make a circle. Okay, so this is how it intersects. You circle, so have the nominal values as well as the diameter, and it can also be a point because a cone have a center line, same as a cylinder has a center line. So when the cone are reduced to a center line, and then when the line intersect with the plane, so it will form a point. So this is the reason that we have 2 solution now, and it depends on what you need to construct. Okay, so let's say I want to construct this circle. Because this circle, it is unable to measure, so what I can do is just measure it as a cone, and then intersect with the plane to get this bigger circle. And so this is my nominal values. After I construct, I will get the actual value also right here. So it's a bit different from the nominal. Okay, so this is how we intersect it. And then if you want to intersect between the top planes, I can choose directly from here also, and the plane tree, then I can get a line. 2 planes intersect with each other is a line. So this is a line, and this is the name, and all these are the nominal value. Okay, so this is how we're going to make the intersections, and then you will get the actual value also. Everything from here for the details. Okay. So basically, how we intersect is just choose the source and then find the target. Okay. Then the next one is a symmetry. So let's say I have this circle, which is the circle 3 and circle 4, and then I want to get a middle point out of these 2 circles. So what I can use is just this symmetry. So circle 3 and circle 4. So you can see actually have a point in between. So my target is always a point, and then it's a middle point. So it's a middle point between circle 3 and circle 4, which is from the center of circle 3 and center of circle 4. Then you can see basically the interface is quite similar. So just now during the intersections elements, we have the source first, and then targets, and then nominal value. And then in here, the symmetry element, we also have the source, targets, nominal value. So it's quite simple, as you need to choose from the source first and then find the target. That's it. Okay, so this is to find something symmetry, which is a symmetry element out of the two elements. Okay, and the next one is connections. So these connections is going to do a line only, meaning to say that it will construct a line from 2 points. So that's why we call it as a connections. So if now I want to make a point, make a line, connect between this one, circle 2, and slot 1. So first I need to select my source first. So now my source will be circle 2 and slot 1. So you can see now I have a line and only one solutions. And then the line will pass through the center of both elements. So this is what we call connections. Okay. So for these three, we can see the interface is similar. And the next one is the construct. So this construct functions is powerful. As you can see, the first part is a target first, instead of what we have in previous functions, which is the source come first, and then this target come first, and then we can choose what we want to construct. And you can see that actually we can construct everything. But now, if let's say I want to construct the circle, okay, I want to construct a circle out of these 4 circles, okay, but I haven't measured these 2 circles yet, so let me measure it. So as you can see, this red line right now is at here. If I continue my measurement, the measurement of a circle will insert after the red line, but I don't want, so I want here. So I click on the line 41 and then click this set insertion point. Then the red line will be at here, and then later if I do any measurements, it will insert after this line. Okay, so I want to 1, 2. Okay. You can see the measurement is insert here instead of before the end. So after I measure finish, I can right click and then set insertion point again. So bring the red line down. Okay, then now I want to construct again. So construct a big circle, which is PCDs, out of this circle 2, circle 4, circle 8, and circle 9. So this is what I want to construct. So construct, and then the target, I need to choose a circle. And then next step, I will select the reference first. So they are on the same plane, and then their reference is XY plane. So this my reference will also be XY plane. And then I can choose the source. So 1, 2, 3, and 4. So you can see in my source here, I have circle 2, 8, 9, 4, which is what I have choose just now. And then here is my nominal value. And then the next one is that you might notice that the circle, which is the yellow preview, is not passing through the center of each circle, like this. Circle 4, circle 9, circle 8, circle 2. So they might not pass through the circle. And the reason is because now there is 2 options, and then we are choosing the element points. So element points means that it will calculate the center of the circle of each circle based on the prop points. And then that it might not pass through the center. So what we need is that we need to choose the element parameter. So this means that for each circle, like circle 4, circle 9, circle 8, circle 2, each element will reduce to a center point. And then all these points, which is point of the circle 4 and point of the circle 9, which is the center point, will construct with each other to form a circle, which is the yellow preview. And this is the reason that now it passed through the center of each circle. Okay. And next one is you can choose your calculation method as what we have in the measurement of the circle. So it's the same options. This square is just the Gaussian method, and all these Chebyshev minimum, maximum, circumscribe and inscribe. So depends on the drawing requirements, and if there's it, then just press Ctrl. So we will have our circle in red. Okay. So basically, these functions we can construct everything. Not only to construct a circle, we also can construct maybe a plane and so on. Yeah, depends on availability. Okay. Then the next one is the top of the cone, but right now is unavailable because we need to make our this cone one, which is the cone that I want to find the top of the cone. So I need to make use of this cone ones and then bring this cone one into the left element window. So double click on it, and then this cone one is at here now. And then if I see now the top of cone is available for me to click. So if you find that this top of the cone is unavailable, you just need to check the left element window. Is your cone one is inserted there? Okay, if not, just bring it in. Then you just click. So now it will prompt you a dialog, and basically you cannot change anything except that the point name, because we will only have one solution for top of the cone. So this is a name, and then just press OK. Then we will get to see this. This is the point for the top of the cone. Then the next one is, okay, so next one is our extract. Later I will measure one more curve so I can extract it out. Let me talk about other first. So minimum or maximum element. So this one is like, if now I want to find the maximum and minimum element of this plane 2, which is the top plane, the red one, and then I can use these construct functions. Okay, let's say this is my source is my plane 2. Okay, and then I want to find the maximum directions of maximum element, which is the maximum points in the plane 2 in the z directions. So here I can choose directions and then put k equals to 1, because if k equals to 1 means that is in z directions. And then now you can see a yellow point, so we can check out our target here. So this is a point minimum. So if you click, you can see there are 4 options. So this will be the minimum point of plane 2. And then you can see that the nominal value for the z will be like this one, negative 0.023. If you change it to point maximum, so the yellow point will come to here, and then the z is higher now, is in the positive side. So this is the maximum point. If you don't want the point, you can have a plane also. So their height is will be at the same level, which is the negative 0.023 for the minimum planes, and then plane maximum will be 0.02. So it's either your choice whether you want a point or a plane. Okay. Then you can see that here is a green tick. Actually, we have for all elements, but right now this green tick is not activated. And if this green tick is not activated and then you press the construct buttons, you can see that actually we don't have the nominal value. We will have the actual value only. So in order to have both, we need to make sure that this is checked and then okay. So you have nominal and actual value. Okay. And then the next one will be the offset point. So this thing a bit similar as top of cons. So it's like now you only have a plane tree at here, and then you can see that I cannot click on these offset points because plane tree is a plane, it's not a point. So I need to have a point in this left element window in order to offset it. So let's say I make use of this 0.5, which is this one, I think. Yeah. And then now this offset point is activated. So I click, and then here is a dialog also. So basically I just need to set which directions I want to relocate this point, which is to offset it. So let's say I want to offset it in these y directions. So like 20 mm in the y directions, these directions. And if I press OK, and then it will prompt out a dialog which is quite similar as before also. So what you can do is just adjust the name if you need it, and then just press OK. So here will be the point. You see this 0.6. So basically if I check this 0.5, the actual value is 66.414. And then after I offset 20 mm for this 0.6, the actual value will be plus 20 mm and then become 86.414 millimeter. So this is how it works. Right now, anyone have anything unclear? Hello. Okay, then I continue. So the next one is offset a line. Okay. So let's say if now I have a plane point here, then the offset lines will not workable also. So in order to let these things to work, I need to have both elements in this element window to be a point element. So it can be a point, it can also be a circle, as long as the element can be reduced to a point. So let me choose, okay, I will choose 0.5 and 0.6. So this 0.5 at here and 0.6 at here. So now I can see this offset line is activated, and then I press it. So you can see now I have a column for me to enter the offset value, and then behind is written that to element and then 0.5. And then why this is 0.5 is because it adapt the elements on the this right element window. This one. Okay. So means that if I enter any value here, is offset to element this 0.5 instead of the left element window, which is the 0.6. So if I want to offset 10 mm, okay, and then I press OK. So you will see a dialog also, and then there will be a two solutions for me. Okay, and then I will illustrate for you why we have two solutions. Let me start a whiteboard. So, can you guys see a whiteboard? Yes. Okay. So now I have this is my point 0.6. Okay. And then this is my 0.5. Yes, this is my 0.5. Okay. So now I am going to offset 10 mm 10 mm to this element 0.5. So basically it's like this. I have a imaginary circle, and then which is here, the offset will be 10 mm. Okay, so like this, and then I will have two solutions. Is because the offset line can be like this. Yeah. And then the other solution is the offset line can be like this. Okay. So this is the reason. And then this thing, this line will always be perpendicular, which is 90 degree to the offset value. So here will be a 90 degree. So this is the reason that we have a solution 1 and solution 2. Okay. Does anyone have any questions? Okay, so this is the reason that why we have two solutions. And then, so if I press OK for these ones, we will have one line at here, and then the other line will be at these directions, just like that. So this is the offset line. Okay, then we have offset point and also offset line. So we will also have the offset plane. So this is the offset plane. If I click, then I have this dialog. So first, I need to offset a plane. I can set the directions for this offset plane. So let's say I set it as facing the z directions first in 1. Okay, then the next steps is I need to select the source element. Okay, so let's say I select this circle 4, circle 8, and circle 9. 8, 4, 8, 9. Okay. Then I will come into this dialog also. So here I can key in the offset. So for this circle 4, let's say I want to offset 10 mm. So after I key in, I need to press this arrow like this. Then here will be updated 10 mm. So the concept will be similar as the offset lines. So it will offset a imaginary circle like that, offset it, and then here I will choose circle 10 also, offset 10 mm. And then here will be 20 mm. Okay, that's it. And then here I can also choose the method, but it's only one method right now. And then okay, and then this dialog is very familiar. All we need to do is just open the offset planes, and then okay. Then we will have this plane. Why circle 9 need 20 mm? It's just illustrations. It's just a example. You can have 30 mm, you can have 40 mm. Depends on how much you need to offset the plane. Like this. Is it okay? Okay. No reply. Then I will continue. You think okay, can. Then the next one is we have parallel. So if I click this, you have a familiar tab, a familiar interface, source target formula value is quite familiar. And then I want to make a parallel line. Parallel line, which is the line parallel with this to this line 8. Okay. So I want to have a parallel lines which is parallel to this line 8 and passing through this circle 1. Okay. So let's see. So first we have 2 columns, and then now this swap element will be useful because for the first column here, we need to enter the elements which we want to have a directions parallel to it. Meaning to say that we need to construct a line parallel to line 8. So here we need to put in line 8. So here look for my point 8, line 8. Okay, like this. And then the next one is I need to pass through the circle 1. So the second column will be my circle 1. Circle 1. Okay. So it will be like this. So if I swap the element, you will see that there will be no solutions. So this thing is important right now. Yeah. So if you swap the elements, which is the circle 1 on top and line 8 below, so the target will be not supported, meaning to say that you cannot construct anything. So I think I answered to your questions, Chinho. Okay. So you can see if I swap, no supported. If I swap against, there will be a line. So the parallel element will be based on what you have on the first column. And then you can see your line and then nominal values. That's it. Construct. So this is your line passing through the center of the circle 1. Like this. Okay. Then for the next one, is perpendicular. So the concept is same as parallel, which we talked just now. It's just that now the line is in another direction, which is 90 degree to the element, to the source element. Okay, so now let's take the line 8 again also, and then passing through the circle 1. So you will see that now we can have a line or a plane. Depends on the availability. So just now we construct a parallel elements. So you will see this red line, which is parallel to the line 8. And then now we are constructing a perpendicular element. So this line now will be 90 degree to the line 8. So actually here will be a 90 degree. And then that's it. Okay. So this line will be passing through the circle 1 also. Okay. Then the next one will be the projections. So projection is like to project something up or something down. So let's say, okay, let me talk this later. And then let me start with the tangent first. Okay, let me make use of the circle 2 and circle 8. So these two circle 2 and 8. And then I want to construct the tangent element. And then if you click, you will see there will be a 3 target element. You can be a line, you can be a plane or a circle also. And I will illustrate this one by one. First is a line. And then if you simply just press OK, you will have 4 solutions. So the solutions will be here, one line. I think it's okay for you guys to imagine, but if you need me to draw it, you let me know. So here will be one line, here will be one line, and then one more line to cross the 2 circles. Like this. Okay. So depends on which solutions you need. And then you can check out the position and directions also. So after you check out, and then okay. So this will be the line. If you choose another solutions, then the line will be in this direction also. And then you will see that the line will be tangent to these 2 circles, which is at a 90 degree to both of them also. So this is what we call tangents. And then let me choose circle 2 and circle 8 again. And then let's try out another solutions. So now we have target element line. And then we can see that this is the reduced right element to point. Meaning to say that if I check this, then this circle 8, which is at the right elements window, will reduce to a point instead of a circle. So after I press OK, we only have 2 solutions, because now actually we are comparing a circle 2 and a point like this. So we have 2 solutions. Either the line is at here or the line is at here. So you can see a line tangent to the circle 2 and passing through the circle 8, center of the circle 8. So this is some solutions. And then the next ones, let me choose circle 8 again. Okay, then the next one is target element is a plane. So let's see what we have. So okay, let me start all again. So if you choose a plane, you can see that this checkbox is automatically checked. So means that the right elements, which is the circle 2 in our right element windows now will be reduced into a plane. So if you press OK, we will only have 2 solutions, and then you can see that this is actually a point, which is the center of the circle 2, and then the other is a circle 8, so tangent to it. Okay. So it will be like this. The plane is actually tangent to this circle 8, and then pass through the center of the circle 2. Okay. So for tangents, we have quite a lot of solutions. And then the last one is a circle. To create a circle. So let's say now I just simply click the circle only. And then you can see I have only 1 solution, meaning to say that there will be a circle in between of these 2 circles, and then tangent to both of them. And then if I press OK, you will see, oh, there's a circle. Other than this, you can also set a radius, like maybe you want the diameter of the constructed circle to be like 15 millimeter. 15 is the radius, sorry, and then the 30 will be the diameter. Either one. Okay. And then you press OK. So we will have 2 solutions. So either the circle is on the right side or on the left side. Depend on what you need to choose. Okay, so this will be the left side. So we are here. So diameter 30. Yep. And then the last one. Is you can check both of them, or you want just check the reduce right element to points. So it will be the same concept. So right now the circle 8 will be the right in the right element window. So this one will be reduced to a point. And then if you press OK, it will be something like this. Yep. So a bit messy, but it's the red color one, red color circle. So like this. And then okay, so now I need to talk more on these extract functions as well as the projections. So for these extract functions, we are going to extract elements like a line or circle out of the curve. So first we need to have a curve first. So I want to measure this slot by using a curve. So first insert a curve first, and then offset it. Okay, let me try it later. So I talk about projection first. Okay, so let's say now I have this plane at here, the plane at this green surface, and then I want to project this circle to this plane. So I can make use of the projections, and then so I need to choose these 2 elements. So this is the circle 5, this one, and this one, which is this plane, will be my plane 7. So circle 5 and plane 7, and if I swap, the result will still be the same. So this swap element is very important only in parallel and perpendicular. Okay, and then the next one is for projections. It can be a point, can also be a circle also. So depending on the requirement. So you can see that if I choose a circle, the circle which is inside the hole now will be projected onto this plane 7, which is at the green surface. So this is how we use the projections. Okay, so you can see we get this circle. And then just now, basically you can see I'm using the input to input these planes. So actually this input is that you can key in you can create some theoretical element, which means that you want to create a point, like I want to create a point somewhere like 30 mm above, and then at the center, and then in these directions. So I can simply create it. But this point is a fake one, so-called fake one, that we don't have the actual measured value. So we construct it out. So like this. And then for this input, we can input everything also, as long as you know these coordinates and the directions and the diameter as well. And then if you extend this arrow, it will shows you the nominal value, because previously we only key in the actual values, and the actual value will always be the same as nominal value if you didn't set it. So if you need to have a different actual value than the nominal values, you just need to extend it up and then key in for both of them, and then press this. Okay, so just like this. You need to press a green tick for both in order to construct it. If only one green tick, then this thing will not be constructed. Okay. So let's say let me try if I am able to extract this out from this curve. Okay, so these functions is actually to extract element out of curve, as you can see. So currently right now I have only one curve here. So I can only choose the curve also. So only choose this curve. And then you can see this cross cursor. So click on the curve, left click, and then right click. And then you will see now I have a target, which is a circle, because this actually forms a circle, but this is just part of the round part. Yeah. And then I can set a range, like maybe I want the points within a 0.1 range from the nominal to form the circle. I can also adjust it also if I want a bigger range or a smaller range. And then all this nominal value and whether it is an inner or outer circle. So in this case, this is an outer circle. So it will be as this symbol. And then this will be the inner circle. So what I need is an outer circle. So basically I take points here, and this is actually outer circle. And this will be the calculation methods, will be the same. And then just construct. And then I basically will get a circle like this. So this will be the circle, the green color one. So I think that's all for the constructions. And I'm not sure if you guys got any questions. If you guys have, just drop me a message or how, and then if not, I will proceed to the features. Okay. So let me proceed to these features. I will talk about this or this. And then for my self, I will put a comment evaluations. So now we have a lot of elements right now. Okay, first is the use this maybe some circle for. Okay, before I start for the evaluations, we have these things called features data. Okay. So this is the feature data. So meaning to say that if later I make any evaluations of the features and then I record the features data, I activate this recording. This record is different from the programs. And then if I activate this, and then the features like maybe the diameter, the radius that I output will show live here. It will show you live here, but it is not in the report yet. It's still it's only show you in the software. And then how do I open this is if I accidentally close this, I need to open this under the Quartis tools, Quartis buttons, and then the work window, and then you check out for the features data. This one. And then you just click on it. So we have this. And then for the first time, definitely you need to activate the recording. Okay, so let's see. Now I have a circle 4. And then I want to evaluate the form durations of this circle 4. If I click, you will find that first is the features. So this is the like ID for you to key in. Like you can follow the balloon number in the drawing. Maybe this is the form divisions in the drawing is like 10, then you put in 10. That's it. Okay. And then here will be your element, which is your source element that you need to use for evaluations. And then just now I said that I need to use circle 4. So I have clicked already before, and then it has been in the left element window. So at here, it will automatically adapt the elements in the left element window, which is the circle 4. But if I want to change it at here, it's also using the same methods. It's just using the drop down list, or you can open up this dialog by clicking on the 3 dots and then choose on it. If you want to know more like which one is which one, because sometimes if we have a lot of elements, there might be a lot of different names, and then you can see from here whether your size, and then to try to see which one is the correct ones. Okay, and then here will be the tolerance. So for a form duration, right, is always have a positive value, or it will not have a negative values. So that's why you will also have a tolerance only, which is the upper tolerance. So you can see it's the UTOL, which is stand for the upper tolerance. And then the durations right now is 28 microns. And then how we determine this is actually this 28 is actually the range. Is different from the roundness. It's just the points. We have take a lot of points, and then the range is actually the difference in between the the minimum and the maximum. So it's 28. Just 9. This one is 0, and then this one is 28. So total up will be 28. If this one is like negative 2 microns, so total up 28 plus 2 will be 30 micron range. So this is just a range. It's not a roundness like this. Okay, so evaluate it, and then we will have our these statistical form durations. And then in the feature data, we can also see this. So this is stand for range, circle 4, our features number 1, and then our actual value, 28 micron. And then nominal value definitely is 0 because 0 is a perfect one. And then upper tolerance 0.1, lower tolerance there's nothing, and then deviations 28 microns, which will be the same as actual value in this case. And then the assessments, which is the percentage format, is 28%. So this is how we evaluate the form. If you want to evaluate for a plane tree, it's still the same. Then you can check out the plane tree right now is 75 because 44 plus 31 is actually becomes 75. So this is the range. It's not flatness also. Okay, then just evaluate. So we have this. So if the result is near to the 0.1, which is 75 micron, then it will show you in yellow, which is the warning area. Okay, and the next ones, I need to check out the diameter for this circle 9. So click this size. As you can see from the symbol also, this is actually diameter. So this is size in what this, and this one is half size, which is the radius. So click on the size, and then we can see there's a lot of more options. First is still the features will be the same, and then the second one is the elements, which is the element circle 9 that I want to evaluate. And then at here you can see these options. So these functions is only available after 2018 and then -1. Then we have add in the 2 more options because during measurements we only have this square Chebyshev minimum circumscribed, maximum inscribed. And then after that we have 2-point size and envelope. If you choose the elements, then it will based on the calculations method, which is what I chose just now is minimum circumscribed. So it will calculate the diameter based on the default one, if you are just choose this. And then if you want to change the calculation method, you can simply change it here, meaning to say that you don't need to go to measure again. So these are one of the benefits of having this. Then you can change here and there. So you will have different deviations. And then this is the 2-point size. 2-point size meaning to say that is like you are using a vernier caliper, and then you measure it around the circle. So it's the same concept. And then in the solutions, if you press the 2-point size, it will show you the 2 result. And then this 2 result is actually the largest 2-point size and the smallest 2-point size. So that's why you have 2 results. But the nominal is still only 1 because your circle is always have only 1 nominal. And then this is the upper tolerance and lower tolerance. And then here is the ISO 286. It's like the fit dimensions, all these, like H7 or H12, all these, like how tight it is to be. So you just need to simply key in. And then this is an inner circle. So for the whole, this must be a capital H. But no worries, it will automatically adjust it for you. So, so it's very convenient. And then you will have 2 deviations also because we have 2 actual value. Okay, so if I press evaluate, under here I can also see two result. Okay, and then you can see this SX and SN. This is the newest functions because previously we in the previous functions don't have this one. It will only show you these 2 value. And then you might be confused if later if I use this envelope requirements. So having this in these new versions, so shows you that this is the SX, meaning to say that is the maximum size in the 2-point size, and then this SN is the minimum size in the 2-point size. So you can see one is big, one is large, one is small. So this is important for you to see in your report. Okay. Then the next one, this square or this will be the similar. It's just calculations issues. And then here, which is the envelope requirement. So basically the envelope requirement is based on whether you are having a inner circle or outer circle. If it is an inner circle, then it will consist of either maximum in scraps and the 2-point size. So you will have 2 results also. So let's say if I evaluate, so you can see we have 2 results, and then this is a inner circle, and then we will have GX, which is the maximum in scraps. It's just the different calculation method, as you can see, the GX maximum in scraps, and then with one more, which is the maximum size in the 2-point size. So some drawing might have this. So what you need to do is just click this, and then it will evaluate automatically for you. Okay, so this is how it works. Same for half size, which is to get the radius. But for radius, we cannot choose the calculations method anymore. The calculation method is only valid for the size. And then the rest, what we can choose is just key denominators, tolerance, plus minus, and so on. Then the rest will be the same. So you will get this radius for smaller r, and then all the value. And then the next one is we can also use size for cone angle, like this, which is the cone angle, this one. We can also use it under size, but not all these angle. So let's say I click size, and then enter the balloon number, and then this is the cone, and then it will automatically change it to the angle format. And then it's like, maybe you think that this is not 59.72 something, you can change it. As long as this is valid for you, then you can change it. It is not, if it is like this in the actual format, then it cannot be changed. And then just key in your upper and lower tolerance as per normal, and then you will get the durations. That's it. So this one is the cone angle, and then is out of tolerance, therefore is in a red color. And then the next one will be the size of this slot, like maybe you want to find the width and the length and so on. So it's also under the size, and then we can just simply key in the features number and then choose our slot 1, and then you will see we have 3 options, which is the 3 component for the slot 1. And then first is the L, which is the length from one extreme end to the another extreme end, which will be nominal value is 32.25, and then we will get this value. And then upper tolerance, lower tolerance, the rest is the same. And then B will be the width, and then Li will be the center of this circle, this one. It will be a point, center point, to the center point of the other circle, and it will be 20. Then if you think that you don't need this and you just need to have the length and the width, you just uncheck this and then leave it this open, and then okay. So for a size, we can use for different components. For a cone that if you need to find a half angle, you just simply use the half size. Then you will get half of it. That's it. So if you see here, usually most of them will be the same. So in the same format, features, actual value, nominal, upper, lower, tolerance, deviations, and assessments. Okay. The next one is the position. So this position is in a one axis, which means that if you click, then you will have 3 different value in each axis. It is not a true positions that combine all the deviations in 3 axes. Yeah, it is different. So once you enter, you can see we can key in the features number and then the elements. If now I want to get the element as my circle tool, just simply click on it. But you need to make sure that this tool is this mouse tool is activated first before you click it, because if now this is a hand tool, you can click it also, but it's actually make it into the left element window. So in order to bring it into here, you need to activate these joysticks and then click on here. Okay, then now you can see the XYZ value. So X, how this is being calculated is based from the origin, which is here. So basically, we can also check from here. So it's 57.5. So the circle 2 from the center to the origins is in X directions is 57.5. And then in the Y directions will be 59.5. And then for the Z is 0 because the circle 2 is being projected upwards. Yeah, that's why it's 0. So no deviations. And then if we don't want it, then just cause it is the same method as what I have evaluated for the slot 1. And then upper and lower tolerance deviations. That's it. Okay, so and you can see a dynamic here. So if you check this, then if you move these coordinate systems, like you move 20 in X directions, then the X value will be updated also. So after you move 20, then the distance between this circle and the origin will be reduced. So it will be like 37.5 and so on. So yep. So this is what you will get. And then now we can actually, okay, so if like we have a lot of circle in these directions, we have a lot of circle, and then they have a equal distance, then we can simply double click on it and then put in some expressions. I will explain this later when we use with the loop functions. Okay, but just to tell you that if you double click, if you prompts out this expression editor, then you can make a more high level program. Okay, so this is positions, and then the next one will be the distance. So distance is finding a distance between 2 elements. So let's say I want to find it between this circle 3, circle 3 and I think this is circle 1. Yes. So I need to choose the 2 elements, and then check out which directions I need. So you can also see from this, you can see from this preview. So for the X directions, you will see in the blue color, which actually will be the same as the axis of the X directions. Okay, so it's the same color. So if you turn off, then we don't have the preview anymore, like this. Okay, so that's it. So this is how we're going to find a distance for 2 points. And then the next one will be the distance. So for example, this plane and this line. So you can see if we choose a line and plane, we actually can have different options to select the this for the element. Mean that you can make it as a line also, and then or if you want to reduce it as a point, also can. And this also same for the plane. You want to make it as a plane or a point, is depends on what you need to do. But at least need one of these to be a point. Okay, so if now both of them are point, then you will have the result in a 3 component, which is the x, y, z axis. But if you make it either one is a line or the other is a plane or what, then you only have a value, because it will find the shortest distance, which is the like this point, and then perpendicular to the have a distance perpendicular to the line. So which is the shortest distance. Okay, so it'll be like this. So depending on your usage, and then the rest, nominal, tolerance, upper, lower, all this is the same. Just follow the drawing and then key in. Most important is this one. You need to make sure that it's the correct one. And then the next ones, if I want to check out the distance between this circle and this slot, this circle and this slot. Okay, so it's a highlight in dark blue, so it means that it's chosen. Okay, but I don't want the distance in the x, y, z components. I want it to be in the polar format, which is the having the shortest distance. Then basically we can just simply change on the left side. As you can see right now, it's Cartesian. So if it's in Cartesian form, then we will have a x, y, z components. But we don't want this, so you just click and then change it to polar. Then we will have our R, and then angle alpha, angle beta. Angle beta is different. It's 0, because right now both of them are on the same projection plane. So the shortest distance what I need is this, the blue color ones, which is the R. So these two I don't need. And then the R will be 49.086 will be the actual value. And then upper and lower tolerance. Okay. Then the next one. Let me make a line first. So now I want to find the angle for this line. this red line. So basically, we will have two angles. So let me talk about the 2D angle first. So if now I want to find the angle between line 13, which is the line I created just now. Where's the line? I think it's the yellow one. And then with this plane. Okay. So let's start one by one. So now you can see that this line is actually slanted in and then is anyhow to be in the space, which is that it have a directions in x axis, y axis, as well as z axis. So first, if I want to find the 2D angle, meaning to say that I need to project both of them to the same plane first, then I can find the angle in between. So let's say I'm going to project it into the xy plane. So basically you can see that this line, this line 13, which is the yellow line, will be projected onto the xy plane, which form this one, this blue line, and then find the angle with the plane 3, like this. And then you can swap it in between. So either find the acute angle or the obtuse angle. You can swap it easily. So that one is a xy planes. And now if you are going to project them to the yz planes, so basically this line, yellow line, you see projected to the yz planes will form this red line. And then what I need to do is just check out the nominal value also, and then you can swap it also. Yeah. So the concept is actually projected the element first before finding out the angle. Same for the zx. So you can see this plane, this line 13 will projected to the zx plane first, and then find out the angle. Okay. So this is how we use the 2D angle. And then if now we are finding the angle, so this angle means the 3D angle. So it will not projected to any plane first, it will simply straight away find the angle in between the two elements. So you can see we will only have one value. So these are plane 3 and then these are line 13. So it will straight away get an angle like this, and then it will be 28 point something. Okay. Okay. Then the next one will be the turning point. So basically, this turning point is like a bit like just now what I have mentioned for the minimum and maximums during the constructions. This one is if I using back the same elements, which is the plane 2, and then you can see I can choose in which directions also. Let's say I want to choose in the z directions. I want to find the minimum value and maximum value, and you can see the minimum value that I constructed just now is negative 0.03, which is the same as here. But right now you are output the value. You are not construct anything. You are output the value. So you will get the minimum and maximums, and the deviations will be total up of these two. It's just like a range. Just 23 plus 20, and then become 43, which is the deviation. So this value will always be the maximums. Always be in the positive side. Yeah, you just need to choose which directions you need. Okay. If you don't want it, just turn off. And then the next one will be the position DAB. This is to compare the actual value and the nominal value between itself. So if I click inside, you can only see I can only choose one element, which is maybe circle 3. So let's find out the circle 3. So first, the D is the durations, means that let me show you the illustrations. So it's like here. So this number 1 is my nominal circle, and then is on the reference plane number 3. Okay, and then after measuring, and I got the actual circle number 2, and then there might be a deviations. So the deviations between its nominal circle and the actual circles will be this D, and then this D will consist of the value of A and B. So this is the case. So it's just finding the deviations between itself. So you will see there are some deviations D, which consists of A and B. And then A is 0 is because the circle is projected upwards also. So there is no difference in the z-axis in this case. So A is 0 right now. And then the B is 5 microns. And then so total up of A and B by using formula, you will get these deviations 5. So right now A is 0, so D will be equals to D. So if I see and evaluate, I will get the value like this. So this is positions for a circle. And then if I want to find the positions for this curve, this one, position, this is a curve 1. So I want to find the positions of each point in the curve. It's very troublesome if I take 1 point, 1 point, 1 point, 1 point, and then I'll put one by a times. Okay, so it's very troublesome. So now the new functions is that if now you choose the curve, and then here I put an underscore, and then inside this curve, actually we have maybe 10 points. And here you can see 10 points. And then right now you can also see that we only have a D and A, we don't have B. And after that, if I press OK, you will see that actually there will be a value for the 10 point. So you can see 17-1, which is the deviations for the first point, which is 25 microns for the residue. And then the second one will be 8. The third one will be 12, and so on until 10. So this is useful for if you want to find the deviations for each point on the curve. Okay. Yes, I think that's it for now. Any questions so far? Yes, any dimension that you wish to output from the CAD model that you want me to do. Hello. Okay, so I think the morning session until now first, and then we start at 1. So you can stay here also as same as yesterday. Yeah. Thank you.
Thanks everyone.